Hello everyone, welcome to IIT-JAM in Chemistry tutorial number 45, and this is lecture number 4 of the physical chemistry chapter solid state. Today's lecture, the subtopic is structure of sodium chloride. Now the D values for 100, 110 and 111 planes for the 4 space lattices such as primitive, FCC, BCC and CFCC are known to all of us, such as primitive. For primitive, D100 is A, D110 is A by root 2 and D111 is A by root 3. This way all the D values are known to us. Now what about the ratio of these interplanar distances for corresponding 100, 110 and 111 planes? This ratio is different for the 4 different space lattices, such as for primitive or simple cubic, this ratio, if it is 1 is to 0.707 is to 0.577, then for FCC lattice it is 1 is to 0.707 is to 1.154. So here it's different. For BCC it is 1 is to 1.414 is to 0.577. Here it's different. And for CFCC it is 1 is to 1.414 is to 1.154. So in these two cases it's different from simple cubic, or in this case it is different from FCC, or in this case it's different from BCC. So all the 4 ratios are different. Now we have to see what should be the XRD pattern of sodium chloride. The Bragg diffraction pattern obtained from 100, 110 and 111 lattice planes of sodium chloride by diffracting palladium K alpha lines, it looks like this. This is the XRD picture. The angles at which maximum intensities of reflection for different orders are now tabulated here. What is the table? Here the table. Look, this is for the first order reflection, this is for the second order reflection, and this is for the third order reflection. But keep it in mind, this is not reflection, but this is diffraction, since the incident angle and the ray which is diffracting after interaction with the crystal lattice, these two angles since are same, so it seems that it looks like a reflection. That is why reflection term is used, but it is within inverted comma. So this thing is already mentioned, but this is not reflection, but we shall use the term reflection here. Okay, so this is for the first order reflection, this is for the second order reflection, and this is for the third order reflection for 100 plane. Look, this value, these two lines are here, but this is a highly intense line, so we have to take this one. So this one has the value 11.8 degree. So if 2 theta is 11.8, then theta must be 5.9. So this is 5.9. So intensity plotted against 2 theta, from this we get this data. For second order reflection, this value is actually 24, around 24. So it is about 12 degrees. So it is 11.9. That is 23.8 was this value. Okay. And for third order it was 36.4. So the half is of 36.4 is 18.2. Now move on to 110 plane. These two, out of these two, the highest intense line is this one, and this one showing the highest intensity at 16.8 degree. So the theta value is 8.4 degree. So this way the first order reflection pattern, if we tabulate this for n equal to 1, 100 would show at 5.9 degree, 110 would show at 8.4 degree, and 111 would show at 5.2 degree. That is 2 theta value was 10.4. This one was considered. But did you mark one thing? Here first order intensity is the most intense line. It is a little less, and this one is the least one. The first one in 100, this one is the most intense, but this one less intense. But in case of 111, the first order is less intense while the second order line is more intense. Why? Okay, we must go to the explanation why this type of pattern is obtained, and this is a very significant pattern because this would reveal the exact type of structure what sodium chloride has. If the first order reflection for n equal to 1 it is considered, then according to Bragg equation, what is the Bragg equation? N lambda equals to 2d sine theta. So the value of n, if it is considered to be 1, then it becomes lambda equals to 2d sine theta. Then in that case the D value should be lambda by sine theta, 2 sine theta. Okay. Then if we take the ratio, then this 2 in the denominator would be cancelled because this is a ratio. Okay. And the corresponding values 5.9 degree for D100, 8.4 degree for D110, and 5.2 degree for D111. These values are put here. And let's take the ratio. Lambda also cancelled due to ratio. Here this value reveals that this is nothing but 1.0.705 is to 1 is to 0.705 is to 1.14. Okay, so with which one does it resemble? Look at this. Here it resembles with this one. Okay, yes, 1 is to 0.707 is to 1.154. It resembles with this one. Okay, this ratio resembles with the theoretical ratio of an face-centered cubic lattice. Therefore, sodium chloride possesses face-centered cubic space lattice. But how does the pair of sodium cation and chloride anion constitutes this structure? In that case, if the sodium chloride is equivalent to a highly polarized molecule like sodium bond chloride, then its center of gravity must be the lattice point. Okay, so if NaCl is equivalent to a highly polarized molecule like Na bond Cl, then there must be some distance between these two ions, and the lattice point should be the center of gravity of the ion pairs. Okay, this means the center of gravity forms the FCC lattice. So that means around this center of gravity there are 2 points. One point is constituted by sodium, another point is constituted by chloride. So one FCC lattice would be constituted by sodium and another one would be constituted by chloride. So this means that the cation and the anion would actually exist in two FCC lattices separated by some definite distance, provided that the two cubes interpenetrate each other. Now I would show you. So this is the structure of sodium chloride, where this black spots or these points, which is being shown by this arrow, blinking arrow. Suppose if this is taken to be Na plus, in that case the white spheres are the Cl minus. Okay, now how do they interpenetrate with each other? Look, this is the FCC lattice formed by the chloride ions, and this is the FCC lattice formed by the sodium plus ions. Now if this one goes to the right direction and this unit cell merges with this unit cell, then the exact structure of sodium chloride is obtained. Look. Okay, so here two cubes are here. One is constituted by Na plus ion, another is constituted by Cl minus ion. So this left hand side and right hand side partial cubes should be eliminated, and this is the final structure of sodium chloride. Okay, intensities of the maximum reflections from any plane will depend upon what? Number one, number of electrons in the atoms or ions in direct proportion, and number two, the order of reflection in inverse proportion. That means for first order it should be highest, for second order it should be little bit lower. Okay, and number of electrons means if it is negative or anion, the intensity should be greater, or if it is cation, the intensity should be lesser. The intensities of reflection maxima obtained from 100 and 110 planes would depend upon the order only. Why upon the order only? For 100 and 110, not for 111? Because both the Na plus and Cl minus ions occur in these two planes, which is evident from the XRD picture. As it had been shown that this line is more intense than this line. This line is more intense than this line. Okay, so this rule is being followed. The order of reflection in inverse proportion. First order is more intense than that of second order. Here also for 110, first order is more intense than that of second order. But in case of 111, okay, this first order intensity is less than the second order intensity. Why? Because the 111 planes are alternately formed either by Na plus ions or by Cl minus ions. How? look at this picture. This line which actually covers these black spheres are the Na+. Okay, here you will get almost no intensity, because what point we have mentioned in number 1, the density of electron. Okay, here the yellow line which covers the white spheres, that is chloride ions, this would be only responsible for the intensity reflection maxima. Okay, hence the second, fourth order reflection would be stronger than first, third and fifth order reflections, since the sodium plus ions are much smaller than chloride negative ions. This is evident from the XRD pattern of sodium chloride. This way, the interpenetrating face-centered cubic structure of sodium chloride is confirmed by using XRD tool. So that's all about the structure of sodium chloride. And now move on to the questions that came in IIT-JAM. This question came in IIT-JAM 2012. You have to calculate the limiting radius ratio of any ionic solid having NaCl-like structure. So let's calculate. This is the structure of sodium chloride. Look, this is 6:6. In the octahedral hole, the formed by chloride ions, sodium ions are occupying, or the octahedral holes formed by sodium plus ions, chloride ions are being occupied. Okay, and this is 6:6 ratio FCC lattice, where two interpenetrating FCC lattices are existing together. Okay, so calculate the radius ratio. See, this is one of the octahedrons. Suppose this is the Na+ ion and these are the Cl- ions. So if they are closely packed, then how does this square would look like? The square would look like this. This here to here, this distance is R positive, and here to here, this distance is R negative. Here to here R negative, here to here R negative. So this edge length is actually 2R negative, and this diagonal is 2 into R positive plus R negative. So if A, that is edge length, is R negative plus R negative, then it is 2R negative. Then A root 2, it is here to here, that is the diagonal A root 2. Okay, it is R positive plus R negative, it would be repeated. That means 2 into R positive plus R negative. Therefore, the ratio, the diagonal by edge length ratio. Okay, what should be that? The diagonal by edge length ratio, that is A root 2 by A. The value, just put the values here. This one in place of A root 2 and this one in place of A. We get this ratio of R plus by R minus, and just calculate, just solve this. A and A would be cancelled. Okay, here you will get 2 and 2 also cancelled. Here you will get R plus by R minus, plus here R minus by R minus would be equal to 1. So 1.414 equal to R plus by R minus plus 1. That means R plus by R minus would be equal to 1.414 minus 1, that is 0.414. Okay, so this is the limiting radius ratio. Next, this question came in IIT-JAM 2010. The structure of rock salt consists of, rock salts means sodium chloride. So you are given 4 options here. We know the structure of sodium chloride. This is like this. So this is actually octahedron. Okay, the sodium plus ions are existing in the octahedral hole of chloride minus ions, and this is definitely a cubic close packed system. This is not hexagonal. So option A, a cubic close packed array of anions with cations in all the octahedral sites, would be the correct option. So that's all for this lecture. Thank you and have a nice day.